And because we have a shortened class, I'm just going to go right up to the bell. Okay, so try to pack up. We're not going to get through everything. I'll finish it on Tuesday. All right, so volume now. Only definition I'll have you do here is the space that occupies a polyhedron. And the first concept I want to get through to you guys is just because a polyhedron looks different from another, they could still have the same volumes. Look at these boxes here I have at the bottom. I have one that's very neat, straight up, one that's a little lenient, and then we got this hot mess right here. Okay. They all have the same volume. They all have the same space inside. Here's why. Anybody want to try to pronounce this mathematician's last name there? Cavalieri's principle. Here's what it says. If you have polyhedrons that have the same height, that's the first condition. It's all three have to have the same height. And they have to have the same cross-sectional area, meaning I slice it with a plane, I hold it up, I slice the second one with the plane, hold it up, and slice the third one. All three rectangles have the same area. The volumes are the same. Okay? I'm going to go through this one more time, a lot more detailed, because last 2 years ago, I did this for like 2 minutes on a May 22nd, second period, and it came up as one of the part 2 questions. And kids are like, when did we do Cavalieri's principle? And I was like, well, for 2 seconds in class. All right, so I am going to go over a little bit more detail. Here's exactly what I'm talking about. What type of prism do I have here? A triangular prism versus a rectangular prism. And you're probably saying, well, they have to have different volumes. No, why not? They both have the same height. When I do a cross section this way of the triangular prism, I get a triangle. When I do a horizontal cut of the rectangular prism, I get a rectangle. But if both of these have the same area, overall, these two will have the same volume. All right, so there's 2 conditions. They have to have the same height right away. And when you take a cross section, those cross sections have to have the same area. I don't care that they're different looking or not. I don't care if one's straight up and one's leaning. All right, as long as they have the same height and the same cross-sectional area. Everyone good there? Cavalieri's principle. We good? All right, now let's actually get into it. Volume of a prism. Go to the last page of your packet. Go to your formula sheet. This is where you're in geometry, you're actually going to get use out of this bad boy, is the volume. Everyone see volume of a general prism. What do you have for the formula? Volume of a general prism. Here we go, 23. Easy, easy back there. Big B times H. Not lowercase b anymore, like 1/2 base times height in a triangle. Big B represents area of a base. That's what big B is, area of a base. So let me just test your knowledge right now in these 3 prisms. Name the shape of the base. Bless you. Name the shape of the base. Here's my rectangular prism. What's our rule? Because you could argue there could be a lot of bases here. What's our rule? As it's drawn, the top or the bottom would be the base. All right. So for me right here, I'll just highlight it in bright green. That would be, area of that would be big B. All right. Okay, second prism. What shape is the base here? 3, second prism. What shape is the base? It's a triangle. Yep. So you would take the area of that triangle, and that would be your big B value. And then finally, my last prism here. What's the shape of the base? 10. Shape of the base here. Hexagon. So I would find the area of the hexagon using 1/2 AP, or divide it up into 6 triangles, and that would be my big B there. Everyone good? All right, what about a cylinder? Go ahead, go back. It's all on the formula sheet. I got nothing to tell you here. I'm not going to try to have you guys figure it out on your own if it's on the formula sheet. Volume of a cylinder? Pi r squared times. And guys, isn't that big B times H? What's the base shape? Circle, area of a circle, pi r squared times the height. Yeah, makes sense. That's big B times H. All right, here we go. Prism. Find the volume of this prism. Volume now. Volume. We're not talking surface area. We're talking big B times H. First question I have, what's the shape of the base? Oh, 16, shape of the base. That is a triangle. So what we're going to do first, I'll put it in red. 1/2. Can you let me know the base and the height of that triangle? It's a right triangle. 25, base and height of that triangle. So 8 times 15. Everyone, hey, quickly, take a look. That's big B. Right there, that's big B. Times the height. Height of the prism. Not of the base, height of the prism. So you guys need to find the distance between the two triangles right now, which would be 10, distance between the two triangles. 8. There it is. Questions? Because I get a little nervous with the height of the prism versus height of the base. When the H stands for height of the prism. You guys are crunching right there, and we end up with, let's see if I can get anybody here. 1. Hello, Meg. Got it. Meters. Now we're doing volume, which is cubic units, everyone, on volume. Cubic units. Everyone good there? Another one. Yeah, you're hungry. Here we go. Rectangular pool. Now I'm giving you the volume. Wow, 1,080 cubic meters in the pool. Length, width, and depth are in this ratio, 10 to 4 to 1. Find each dimension. What are you doing with that 10 to 4 to 1 like we've been doing all 35 weeks of the school year? Putting x's with them. So 10x to 4x to 1x. If the volume is 1,080, I'm going to set 1,082. 10x times 4x times the height, or the depth in this case, 1x. Whew, how many algebra champs in the house now? 15. Algebra champ? Who is it? All right, I'm not even going to ask. 10x, 4x, and x. Correct. Next step, Orion. Not out of the woods yet. You cannot take this cube root of this yet. It needs to be by itself. So yes, divide both sides by 40. X cubed equals 27. Now, I'm sure you know what to do, maybe not where to go on your calculator, though. We're not taking the square root. We're taking the cube root of 27. Now, you have 1 of 2 ways to get there. Everyone, no matter what version of calculator you have, can go to the math button on the left-hand side, and it'll be there. It'll be a choice. If some of you have you can get a fraction template. Some of you can hit alpha window, and you'll see it there as well. Okay, so you can either under the math button or alpha window for a couple of you. And the value of x turns out to be cube root of 27, 3 meters. Yeah, you're darn right we're not done because that's 1 out of 3 dimensions. 3 meters is the depth. How about the height and the width? Or the length? Length will be, we called it 10x. Here you go. Oh boy. Boy, here, 29. Length. Thanks, Dan. The suspense. 21 length. 30 meters. And how about the width? 16 meters. 16? Watch your mouth. Oh, boy. Here we go. 12. Thank you. Issues? Yeah, another one. Yep. Jed. He bought a generator that's in the shape of a rectangular prism. Guys, his generator can only last 2 hours on a liter of gas. So that generator right there, how many hours can it last? These problems I love so much because you just don't find the volume and you're done. I gave you a little conversion here. 1,000 cubic centimeters equals 1 liter. I got a quick question before we start. Why is this volume and not surface area? That's what I'm asking. Okay, one of two ways. Yes, you're filling it up with gas, so inside, or they gave you this conversion, which is in cubic centimeters. All right. Why would you just cover it with gas? Okay, so the volume, big B in this case would be 15 by 20. Height of the prism, 10. Oh, I just said the number 10, but thank you, Maggie, for it was just part of the problem, so that's why I said it. It's okay, but thank you for your determination. So there's the volume, but I need to get it in gallons. And there's the conversion right there. There's 1,000 cubic centimeters in a liter, gallons is coming up, in 1 liter. So how do I get this 3,000 into liters? 9, how do I get it into liters? Divide it, yes, so 3,000 divided by 1,000, I have 3 liters of gasoline. And the generator can run 2 hours on a liter. How are you going to find me how many hours this beast will last? 11, how many hours? What's that? How do we get it? 3 liters times 2 hours a liter, or 2 hours a liter. Yep, 6 hours. Hey, can we get, these are famous here on this half of this unit. I don't care that you can find the volume of a rectangular prism. I hope so, but can you do something with it? Anything else? Keep it going. Yep, you got it. Ah, no! Well, we better go quick, huh? But we better hurry up here, ladies and gentlemen. Shatter, pinwheels, swing, clock, swing, genie. What else? Star, nope. Curtains, got slide. I'll give you both. Drop. Okay, we ready? Star. Any stars? Curls. Curls. Fades. Curtains. 1, 2, 3, 4, 5 curtains. Slides, I'll give you both. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Drops. Cubes. Shatters. Pinwheel. Clock. Swing. Genie. Okay. Slide either way. Here we go. Or Promethean Man. How much? Got 10 seconds. Slide or Promethean Man. Here we go. Fade. The old fade. Sorry, everyone. Quizzing it tomorrow.